implicit derivatives. All right, so we've been going over derivatives for a little bit, and now we're going to get into implicit derivatives. All right, so normally with derivatives, it says usually derivatives are done after you have the original equation written like y equals some equation. I wrote blah. Okay, so y equals some equation. All right, that's usually how you take a derivative. Well, that works great until you have a problem like this. X squared plus y squared equals 9. Because to solve this for y, you'd have the square root, it'd be plus or minus, just be kind of a hassle. All right, so that's where implicit derivatives come into play. Implicit derivatives work for any problem where you can't easily solve for y. So how do we do this? Well, you do a derivative of every term, even the y terms, just like normal. But if it's not an x term, you multiply on a y prime, should have a little 1 right there, a y prime symbol. Then after that, you solve for y. All right. It may sound a little complicated there, but let's look at a problem and see if it gets any easier. So let's look at our x squared plus y squared equals 9. So take the derivative of x squared. That's 2x plus. Now take the derivative. I'm going to change colors. Take the derivative of y squared. Well, you do it just like you did the derivative for x squared. So it would be 2y. But now you have to multiply on a y prime equals, and then go back to black colored pen. Derivative of 9 is 0. All right. So this here, this 2y right here is your normal derivative, so to speak. That's your normal derivative. And then your y prime here, you had to add it on because it wasn't an x term. All right, so this happened because this, oops, second right, wasn't an x term. All right, so with implicit differentiation, you do derivatives like normal, but every term you have that is not an x term, you have to add y prime. All right, you have to add y prime. All right, so that's step one. Step one is do all the derivatives. I'm going to put the steps over here. Step one, do all derivatives. Now, step two is solve for y prime. All right, solve for y prime. I think I forgot to put the prime symbol in that last video because you can't really type that symbol very well. I think I forgot to write it in there. But it should say solve for y prime. Let me check. Fade this back in. Yes, this should say y prime. Solve for y prime. All right, because that's what we're looking for here is y prime. All right, so now back to here. Sorry about flipping back and forth. So now we're going to take this equation, 2x plus 2y, y prime equals 0, and solve it for the y prime. So I'm going to rewrite it down here so I have it to work with. So minus 2x minus 2x. So 2y, y prime equals negative 2x. Divide 2y, divide 2y. So y prime equals, because the 2's will cancel, negative x over y. So this is the derivative of x squared of x squared plus y squared equals 9. Alright, so what we did was find dy dx. When you have an implicit derivative, you'll see that this says dy over dx. Instead of just d over dx, it likes to be dy dx. Alright, so I'm going to have you try a problem. Alright, it's a little tougher than what I just did, but follows the same rules. First, you do all your derivatives. Alright, so for here we did 2x plus 2y, and then y prime because it was an x, and then the 9 goes to 0, and then you solve for y prime. Alright, so this works the same way. This is the u try. It works the same way, it's just a little bigger problem. 3x squared plus 2y squared minus 4y cubed equals 0. I want you to find dy dx. So I'm going to stop talking for about 5 seconds. That'll give you plenty enough time to pause the video. And then after you get done working it out, unpause the video and I will work through it. Alright, so let's get this solved. So we're going to take derivative here, which is going to be 6x, plus 2y squared will be 4y. Don't forget though, you need the y prime. Minus 4y cubed, the derivative of that is 12y squared. Don't forget y prime equals 0. Now let's solve for y prime. Subtract 6x from both sides. So 4y, y prime, minus 12y squared, y prime, equals negative 6x. Factor out only the y prime. I know we could factor out a 4 as well, but since we want to solve for y prime, only factor out the y prime here. So y prime, and then you're left with 4y minus 12y squared equals negative 6x. Divide off the 4y minus 12y squared. Divide 4y minus 12y squared. So that means that y prime equals negative 6x over 4y minus 12y squared. Alright. Or you could factor out a 2, so you'd get negative 3x over 2y minus 6y squared. I would take either answer. Right? I would take either answer. So that's all there is to implicit derivatives. Don't forget though, if you have fractions, you need to make sure you do quotient rule or change the exponent to a negative number and do product rule. If you have functions within functions, make sure you do chain rule or the GTC 13 rule. All right, so I'm going to show y'all one that does use product rule. That's x squared plus 2xy minus y squared equals 4. All right, so this one we're going to have to use the product rule. Why? Because we have 2xy. So that's 2x times y, so we're going to have to use product rule for that. All right, so this will go to 2x plus, remember product rule is 1d2 plus 2d1. All right, so the 2x is going to be the 1, and the y is going to be the 2. So this will be 2x, so that's 1. d2, since it's just a y, it'll be 1 y prime, or just y prime, plus 2, which is y, times the derivative of the first one, which is just the 2. And then, of course, minus 2y y prime equals derivative of 4, which is 0. So let's clean this up a bit before we get moving. So this is 2x y prime plus 2y minus 2y y prime equals 0. Now we need to solve it down for y prime. So first thing we're going to do, subtract the 2x from both sides and subtract the 2y from both sides. So 2x y prime minus 2y y prime equals negative 2x minus 2y. Factor out only the y prime here, because that's all we're concerned with. So that's 2x minus 2y equals negative 2x minus 2y. Now divide the 2x minus 2y by both sides. Oops, it's supposed to be positive. I'm going to move that bar up too. 2x minus 2y. So y prime equals negative 2x minus 2y over 2x minus 2y. I would take that answer, or you could factor out a 2, and I would take that answer, negative x minus y over x minus y. Either answer is correct. All right. So even though it's an implicit derivative, we still had to pull in the product rule in order to solve it correctly. All right. So anytime that you have an x and a y together like that, because it was 2xy, you're going to have to use the chain rule. I'm sorry, the product rule. But don't forget about those rules. Just because you're not doing a normal derivative doesn't mean they don't still apply. All right? So there's no ticket in the door for this one. So see you tomorrow. Make sure you know how to take implicit derivatives.